go. Yeah, I see people starting to come in.
Mhm.
So hello, everyone. We're having people start to join us, so that's great to see. And very delighted to welcome you today to our online blockchain at UBC monthly research talk. Now, there's a little bit of history to this talk in that this would have been the time that we would have organized our annual conference, which, as you know, is kind of a big event for us at Blockchain at UBC, where we bring together industry partners and academics and students. And Drummond Reed, our guest speaker for today, was going to be a keynote speaker at our conference. So COVID-19 had other plans for all of us. And as we're now socially distancing and in our various locations, we can replicate at least some of what we were planning to offer in the annual conference online. So we're really delighted that Drummond agreed to give us the keynote talk that he would have given at our annual conference today. And it's a perfect follow-on to a recent event that we organized at Blockchain at UBC, our witness seminar on the question of whether governments achieve public health and fight the COVID-19 pandemic, as well as respect privacy. And so we had a really amazing discussion on that topic on May 5th, and the proceedings will be coming out at the end of the month on that. But a lot of questions came up about the kind of technology that Drummond is going to speak to us today. So before he begins, I just want to give him a brief introduction for those of you who may not know Drummond already. So he spent over 2 decades in internet identity, security, privacy, and trust frameworks. And he joined Evernym as the Chief Trust Officer. I love the title, after Evernym acquired Respect Network, where he was the CEO, co-founder, and co-author of the Respect Trust Framework, which was honored with the Privacy Award at the 2011 European Identity Conference. And Drummond is a trustee and a secretary also of the Sovereign Foundation, where he serves, and some of you may know Sovereign as a particular blockchain platform network that is all about self-sovereign identity, where he serves as chair of the Sovereign Governance Framework Working Group. He's co-editor of the Decentralized Identifiers specification in the W3C DID, Decentralized Identifier Working Group. He served as co-chair of the OASIS XDI Technical Committee since 2004, the Semantic Data Interchange Protocol that implements privacy by design. Prior to starting the Respect Network, Drummond was executive director of 2 industry foundations, the Information Card Foundation and the Open Identity Exchange. And he served as a founding board member of the Open ID Foundation, ISTPA, XDI.org, and Identity Commons. In 2002, he received the Digital Identity Pioneer Award from Digital ID World, and in 2013, he's cited as an OASIS Distinguished Contributor. So Drummond is a thought leader in the identity, security, and privacy space of no small note. And so we're really, really delighted to have you here today. Thanks so much for taking time, Drummond, because it is a holiday where you are, I understand. So we particularly appreciate your taking the time. So I'm going to turn it over to you now to give us your presentation.
Sure. Thank you very much, Victoria. The holiday actually was yesterday, Memorial Day here in the U.S. So now we're back to work, and happy to be here. As I was mentioning, my younger son was able to come home. First household guest we've had in 3 months this past weekend, so it was a cause for great celebration. So thanks very much. Just to help make it clear to folks that, because I do wear all these different hats. So my day job is I am, as you said, Chief Trust Officer for a company called Evernym. headquartered in Salt Lake City, but we have a group here in Seattle, also in London, and in Belgrade, Serbia. And we are a commercial vendor, SSI software and solutions, is what I call a pure SSI company, based on the trust over IP stack we'll be talking about today. Now, back when Evernym, my startup was acquired by Evernym, Respect Network, because it was recognized by Evernym that wrote the original code for what's now HyperLedger Indy, that it needed to have, that needed to be a global public utility, and it needed to be governed by a nonprofit organization, and that became the Sovereign Foundation. And so that's how I became involved with that. So you'll hear about that in today's presentation as well. And then Evernym contributed the code to Sovereign Foundation. Soon after that, Brian Bellendorf became the executive director there of HyperLedger. Brian, a lot of folks may not know, he's actually been in identity for a very long time. And we opened a dialogue with him and said, well, that code could be part of a larger the HyperLedger community at the Linux Foundation, and he welcomed that, and that actually happened very quickly. And so that's how what Sovereign is built on, and what Evernym is building on is open source, has been implemented at HyperLedger. And for folks that are deep in the blockchain space, this is the HyperLedger greenhouse, as they call it, of the different projects there. When that code was first contributed, it became called HyperLedger Indy. It is the blockchain OS or operating system or network software among the different frameworks that is optimized for self-sovereign identity. And specifically for public permissioned networks for SSI. As it grew, it then spawned, because it had some of the most advanced crypto. That's where it had zero knowledge crypto libraries, because they're needed for privacy. It became the seed of what became the shared crypto library for all HyperLedger projects. That's now HyperLedger Ursa. I think it's about a year old now. And that is the one crypto library, like I said, that all HyperLedger projects now are using, standardizing on, as well as anyone else who needs it. And then, as I'll explain further today, as we started moving up the stack from the ledger to the digital wallets and agents needed to use that for self-sovereign identity, that spawned the HyperLedger Aries project. And that's where a lot of attention and energy is going into development-wise today. So I'm just giving you a sense of sort of the progression over the last 3 years of these projects in HyperLedger. Now, of course, that's just one set of implementations of the standards and the stack that we'll be talking about here today. So I want to start out just making sure that the core reason for this new identity model, SSI, this and verifiable credentials, is clear. Why is this? Why is it taking the digital identity world by storm? And every time I present, I start out with the analogy of, we already have self-sovereign identity in the real world. It's right here. I guess I have to hold that in front of me. It is the way that we carry credentials in our own wallets. We obtain the credentials from any issuer of credentials in the world that we need them from. We carry them, hold them privately, and then we present credentials that are needed by parties we call verifiers to turn around and when we need to prove something about our identity in order to establish trust relationships. All we're doing is taking that whole process and moving it, I get my other prop here, onto this, right? We need the ability to do that digitally and over a network. And conceptually, that seems quite simple. Obviously, the devil is in the details. So the core standard needed to do that is called verifiable credentials. It became a full W3C standard last September, the 1.0 standard. And this is what they call the trust triangle, that it's the very heart of it. And again, this applies as much to the credentials in this wallet as it does into digital credentials. And every credential has an issuer that for a digital credential digitally signs a credential, goes to the holder into their digital wallet. And then when the when the holder needs to go and present a credential to a verifier that needs a proof of one or more of the claims or attributes in those credentials, that's prepared out of the holder's wallet, presented to the verifier. Now, what makes it all work, the digital cryptography, is this piece in the middle we call the verifiable data registry, generically, of which it's important to point out a blockchain is only one potential solution or implementation of a verifiable data registry. So we'll go through this in a little bit more detail. There are other ways to do it, but the ability of blockchain technology and the cryptography it uses and the qualities it has as a decentralized, consensus-driven system are really ideal for underpinning this decentralized model for digital identity. So to make this, to really, crystallize this, what do we mean by this kind of digital credential? I want to point out this is about a month ago, CoinDesk carried this article about COVID-19 credentials. They unfortunately chose the term immunity passport, which has become quite controversial around, A, the science, and B, some of the implementation issues around this. But this is some more text from that article that just explained that COVID-19 credentials could be produced without compromising the privacy of users. And this could help us in reopening our economies in the various countries around the world. Now, this initiative, at the time this was written, it was 60 organizations. It's now over 100 are involved in supporting CCI Credentials Initiative. These are 10, I believe they're up to 12 use cases now of the different kinds of digital credentials that the CCI initiative volunteers are helping create, define, create the governance frameworks for, as we'll talk about. And some of these, test credentials and the science behind them are much more controversial than others. The one that we've seen almost universal support for is healthcare worker mobility. If you have doctors and nurses that now need to move around among facilities such as in the NHS in the UK, which has nationalized healthcare, having a credential that can be quickly scanned and validated that you're a real doctor, real nurse moving between hospitals. Their own studies suggested last year that they could save 44,000 doctor days per year by moving from paper to to digital credentials. That's not just a huge cost savings, that's time that doctors and nurses can spend with patients, and we need that more than ever with COVID-19. So that credential, which NHS has referred to as a digital passport, again, it was put into pilot, a proof of concept last fall. Now it's being pressed into full production fairly rapidly. Expect to see some more announcements about that coming out here shortly. But it's already, I mean, this is a real production digital credential being deployed to help with one aspect of the biggest health crisis we've had in many decades. So what we're talking about here today is not theoretical in the slightest. So I'll actually pause just there for a minute and check with Victoria and Michelle. If there are any questions pending, let me know. Otherwise, I'll keep going.
Yeah, we're not seeing any, but I'll just encourage participants to post your questions, which Drummond has said he'll take, as we go along, into the Q&A section. So you should see a Q&A in your screen, on your screen there at the bottom on the right-hand side. And then that's where you can post your questions, and we'll just check in periodically. And then there'll be time at the end also to respond to questions too. So looking forward to having your questions.
Perfect. All right, let's not dive in a little bit of understanding. This isn't going to get super technical, but I want to make sure that the core of how this process works is clear, because I want everyone to understand what is the role of blockchain in underpinning this new digital identity infrastructure. So again, here's another depiction of the verifiable credential trust triangle. A little bit more, I call it my Tinker Toys version, because I want to step through how it actually works. So again, we've got the issuer, holder, and verifier roles here, and when we talk about those roles and the protocols that will go on between them, uh, all of them are operating what we call agents. And that any software, I mean, any device you're using for a holder, if it's an individual, of course, it might be a smartphone, could be a tablet, could be a laptop, a PC, a car, whatever computing device they might be connecting with. Issuers and verifiers, typically they're servers, but they don't have to be. One of the popular deployment scenarios we're seeing for verifiers is actually iPads, and we'll step through how that works. And then again, the baseline here, whatever system they want to use a verifiable data registry, we're going to talk specifically about blockchains here today. So basic process again, step one is the issuer of the credential is going to write to the blockchain. They're going to use a DID, a decentralized identifier. It's a new identifier standard that has been developed specifically for cryptographically verifiable identifiers that do not need a centralized registration authority. And blockchains are perfect for that. So the simplest way to understand a DID, it's an address of a public key and any other associated cryptographic metadata on a blockchain. And there are various different ways. Every different blockchain or backend system has its own what we call DID method. The issuer chooses the method, and the blockchain or verifiable data registry they trust, and they write this data. Now they're set up to be able to start issuing verifiable credentials. So they then use the associated private key for that DID to sign the digital credential that goes to the holder and into their wallet. Now, when the holder goes to a verifier who requests a proof of that credential, it might be to log into a website, it might be to qualify for a loan, it might be to um, uh, uh, go in and fulfill a certain task at an employer. They produce a proof of that credential, which will contain the DID of the issuer, right? And the verifier uses that to read the public key and other metadata from the blockchain. So they, to the extent they trust that system, they can trust that association, and now they can verify the credential, the proof, and whatever data has been provided. Now, that's only valuable to the verifier if the verifier trusts the issuer, right? All the credentials in this wallet only mean something if I present the credential that an issuer that a verifier needs, because they trust the issuer of that credential. The breakthrough of this model is that no integration is actually needed between verifiers and issuers. This entire infrastructure does not require them to talk to each other at all. And that is in contrast to federated identity protocols, in which all the verifiers are tied into the identity providers that are issuing or providing authentication. And of course, entirely different than centralized systems where you're all connected or have accounts with the centralized identity provider. So this is really the key to why this new decentralized identity model, or SSI as it's called, is because it allows holders to carry a set of credentials and verifiers to decide whatever credentials or whatever combination of credentials they can accept to meet their own trust requirements from whatever set of issuers they accept will work everywhere. Again, it takes our model for how we use credentials in the real world today and just brings it online in a way where it's not centralized, and yet it provides strong cryptographic verification. So that's the core model. Now let's make sure, let's illustrate this, and we'll take that doctor's passport that we looked at NHS and actually step through exactly what is, again, in production as of this time, and will be rolling out progressively more over the next month or two. So in that case, the issuer of that credential is the National Health Service in the UK. They are actually writing that DID and public key to the sovereign blockchain. And then they're in a position now to issue a doctor's passport credential, which they will sign with their private key. And that is issued to a doctor that will keep it in a mobile wallet. There are several of these mobile wallets that are compatible right now using HyperLedger Aries. And that doctor now is able to go to, for instance, and provide a proof of their license to a hospital. And it is as simple as the hospital typically will have an iPad at a point of entry with a QR code that the doctor scans to get the proof request from the verifier. One touch to accept that and provide a biometric to unlock their wallet on their smartphone, and that proof is passed to the to that iPad, which is running the agent. That agent will turn around and take the DID in that proof, check the blockchain to get the public key and other metadata, and then it can verify that proof. And as long as that was produced by an issuer authorized by the NHS, the doctor's in the door. That whole process should take, less than, I mean, the entire scan the code, approve, on in, definitely less than 30 seconds, down under 15 seconds is what it should take. The actual cryptographic and network operations only take a couple seconds. So that's the core of how the whole system is working, with example of one credential from one issuer and one ecosystem is the term we use for it. So that's the basic mechanics. Now again, I'll stop and just check and see, because I don't have the Q&A up. Oh, I do see, actually I can bring the Q&A up. There it is right there. I can keep an eye on that. Which of the three entities store the holder's private key? Let me back up one slide here. Whoops, right here. And I'm going to back up here to this one. So the holder has a private key in this case, but the holder, there are two options for the credentials. There are three types of credentials, or call it credential signature format, supported by the W3 specifications. In two of those, the holder has their own private key and will sign the credential or countersign the credential when it's given to the verifier. So the verifier knows that it came from, an authentic holder. When that's the case, the holder will also have a public DID on a blockchain or a system the verifier trusts. While that works perfectly well cryptographically, it does have a major privacy issue, which is not only is the DID, but the holder signature is a perfect tracking beacon. Every place they use that credential, they, regardless of if they selectively disclose information from that credential, their DID and their signature is exactly the same every place they use it. That's how cryptography works. Architects from Evernym and others in the HyperLedger Aries project recognized this several years ago and said, the only safe way for holders to provide a proof that they are a legitimate holder of that credential without providing a public DID and signature that can be correlated everywhere is using zero-knowledge cryptography. So the third option for credentials in the W3C standard is one that uses Comenius Licentia signatures, and the holder does not actually share a private key. What they do is they share what's called a link secret with the issuer, which is used when the issuer is encoding a zero-knowledge credential that goes into the wallet. At that point, only the holder of that wallet that has that link secret can produce a proof of that credential. So the holder does not need to sign the credential. They need to produce the proof that uses that link secret. The link secret is never revealed to the verifier, so you can't correlate on it, nor a signature. but the verifier knows it came from that holder that was issued by that issuer. So in that case, the holder is not storing a private key to sign the credential. They don't need to. Only the issuer is storing that private key. And then I see a question: should the issuer register himself or the? Typically, it's an organization. Doesn't have to be an individual. Yes, they will. This registration, they actually generate in the sovereign DID method. You generate the public-private key pair and the DID that's based on, and then you register that with the sovereign blockchain. And you do that before you start issuing credentials because they will contain the DID. So I hope that helps answer those first two questions. I'll keep an eye. I'm going to put that over to the side, and I'll keep an eye on that on the question list. All right, now I was about to explain a little bit more about. We talked about public DIDs being on the blockchain and the reason for that, so issuers can be trusted by verifiers anywhere. I want to go further into why holders do need private keys. They need to do DID exchange, but in the HyperLedger Aries architecture, they're able to do all of that off-chain and completely privately with what we call PeerDids. So every time a relationship is formed between any two parties, in this case, the holder-issuer relationship, they use what's called the PeerDid Protocol to exchange DID documents that are only, they basically generate key pairs and exchange DID documents in a protocol that's a protocol version of Diffie-Hellman key exchange. The result is they end up with this connection, we call it a DID-to-DID connection, where each of them has the DID document for the other, which means not only can they use this for secure and private messaging between the two of them for anything that needs to be exchanged, not just digital credentials, but secure messaging or data exchange protocols, but they also now can support key rotation and revocation within this relationship. So it's not just a one-time key exchange. They can rotate keys as needed and maintain that relationship forever. And I'm going to pause there and make sure you understand, I mean, forever. The key is there is no intermediary in this relationship. It is based on, unique cryptographic values that are exchanged between these two, and this can travel over any channel, any intermediary, anyone in between. It can be peer-to-peer or mesh network, NFC or Bluetooth connection. It can go over IP. It can go over however you can move messages between those two, but they can be end-to-end encrypted in either direction and mutually authenticated. So we at Evernym and the HyperLedger Aries project, huge believers in DID-to-DID connections and this whole layer. And so each of these are unique. Every time you need to set up a new relationship, so when the holder goes to verifier, they first form a DID-to-DID connection, and that's where the proof requests and proof responses will travel over that. Okay, so I love it. I can almost set a stopwatch until the question comes from Albert here. Are private keys recoverable by the holder in the inevitable event of wallet loss, such as losing a mobile device? So the answer is there's a whole branch of SSI infrastructure devoted to key recovery and wallet recovery. The simplest approach, and I led the team called where we worked on a project funded by the U.S. Department of Homeland Security, a year-long project to develop what we call DKMAS, Decentralized Key Management System. And we investigated two recovery modes or strategies. Traditional offline recovery, where when you set up your wallet, you print out or do offline secure storage of a recovery key, and then your wallet, an encrypted backup is maintained locally, or in whatever medium you choose. And then, of course, if you lose your device or your device becomes corrupted, you recover from that, and that certainly works. We also invested in what's called social recovery, which is, and there's an entire protocol for this. In fact, I can share a link a little later on in the DKMS design and architecture document that is publicly in the HyperLedger Aries repo. Social recovery, the agent that you're using here at the holder, actually, A, it maintains an encrypted backup in the cloud of the wallet, and B, it shards your recovery key and keeps shards of it with your choice of trustees, any set of relationships you have, either with other individuals or other organizations. So recovery there does not require having to have physical access to another copy, and it can be done in as little as a few minutes, as long as you trust those trustees to not collude and to be available when you need to recover. So those are two options there. All right, I'm seeing another question, but I'm gonna hold off on that one so I can keep going here. Some of these questions I think will be answered, but don't worry, we'll try and get to them. Yeah, I do want to answer this last one that just came up. So if you have a did connection and you share credentials over it, the connection is independent of the credentials you share. In either direction, by the way, you can have mutual authentication in both directions. So the connection lives at one layer, the credential exchange at another layer. And when we go over the stack, you'll see the difference between layer 2 and layer 3. As you form connections, again, person to person to organization, person to thing, or any combination of those, connections are yours. They live in your wallet or wallets if they're synchronized forever, as long as you want them and the other party wants them. Either party to a connection can delete it at any time, and it's, it goes non-functional. And that's also how all of what's happening here above the blockchain, it's very easy for that to be fully GDPR compliant or compliant with HIPAA or CCPA or other privacy laws, because there is no blockchain-based storage. You need to be very careful about what's stored on the blockchain or other immutable public ledger, because personal data there is very dangerous. I'll put it that way. All right, so I'm going to keep going. I'll stop again as soon as I'm done with the next section. Now, before we can build a full stack, there's one more special role, and that's governance frameworks. I want to explain the problem we're solving there. So again, if you look at the trust triangle, you go, this is great, but how can verifiers know what issuers they trust? The larger a network might grow, the bigger a problem that becomes. It's just like, hey, when you know all the people in a little village, you know who you can trust. But as you start to expand that, how do you know who you can trust? So the answer there is a second trust triangle that we call the governance trust triangle. And this is the key to scalability, but also to forming trust relationships across trust communities or transitive trust. So here we have a governance authority, which can be any form. Don't read just government. Certainly governments are governance authorities, but they can be consortia, they can be companies, universities, churches, schools of any kind, cities, any trust community that says we want to establish a set of rules under which we're going to operate, publish them as a governance framework, can serve as a governance authority. So we're democratizing how trust can be managed online, as opposed to the current web PKI system, the lock in your browser. I like to point out to folks, who's the governance authority for that? It's a group called WebTrust, which happens to consist of 5 browser manufacturers around the world. The PKI system that we're all using for the web today is actually managed not by governments, not by government agencies, not by by 5 browser vendors. So this is why we want to move to something that's more robust, more democratic, more decentralized than 5 browser vendors. So governance authorities, they publish their policies for governing their ecosystem. And one of the things they do is say, who are the authorized issuers in that network? And now if a verifier trusts the governance authority, it can determine in several different ways that any issuer is authorized by that governance authority, and therefore it can accept the credentials. Now, if you look at this model, you say, well, how does that work in the real world? In fact, this is exactly the model that underpins some of the largest trust networks out there today. MasterCard, for example, is the governance authority for its entire network. The issuers that it authorizes to issue credit cards today are banks or financial institutions. They issue those credit cards to card holders that put them in their wallets, and then they go to their verifiers or merchants, and they provide proof of a valid credit card. I show you this analogy because we're about to talk about the Trust RP Foundation. MasterCard is indeed one of the founding members, and this is the same model they're proposing now to follow for digital identity and verifiable credentials. So if we want another example, let's look at that doctor's passport. Well, in that case, the governance authority is the NHS in the UK. What they're actually doing is they're authorizing any of their authorized providers, that would be hospitals or other medical care providers in the NHS, will be able to issue credentials to their own doctors and nurses. That in turn, Credential now, a proof can be given to anyone that needs a proof, such as other hospitals that doctor needs to go to, that whole scenario we provided earlier. So you can now see that these governance authorities and their governance frameworks are tremendous leverage points, no matter what scale the network. It could be a global network like MasterCard, could be a national network like NHS, it could be an industry-based network like GS1 is looking at creating for the supply chains that they provide infrastructure for around the world. It could be a regional school or university network of universities that want interoperable learning credentials. Many examples, cities of all size. So this is the key role that governance plays in this whole ecosystem. And one more example I want to bring home, because we're one of the other founding members of the Trust ToIP Foundation is the province of British Columbia. And they're in the process now of starting to build their governance framework, which of course, BC government is the governance authority. They already have implemented a situation where BC government agencies are issuing credentials to businesses in the province of British Columbia, who will now be able to provide a proof of their corporate certificate, health insurance, health certificates for restaurants, any other kind of business credential issued in BC can now be proven to any verifier who needs it, like an inspector. And this, again, is also up and running in the form of the BC Gov, they call it the org book service. You can see it at vonx.io, vonx.io. This is an operating service that's been in production for, I think, almost 2 years now. All right, we'll take one more. I'll finish with this point about, so you have to think of digital credentials and governance frameworks, two sides of the same coin. This is part of what makes it so powerful. It's not just about technology, it's about the governance. So we need the business and legal and social rules that go with that technology in order to produce real trust. So I will take one more pause here to see about, oh boy, questions are really rolling in. This is great. All right, back up a little bit. Kyle Fairfield asks, what is the benefit of using blockchain to store the DID when the verifier could just check the certificate validity? It's a great question. Think of DIDs and their associated documents as digital certificates on steroids. Now, by steroids, what I mean is currently digital certificates rely on a relatively small set of certificate authorities. They're centralized and they are single points of failure, and they're dedicated, unless you're using an extension, there's a very sort of fixed set of metadata. What they're doing is they're certifying your public key. With verifiable credentials, we're saying, first of all, anyone can be an issuer. Your public key is you are verifying it by proving that you control it to a blockchain or decentralized system. So you're removing central points of failure, and you're making it dramatically easier and faster for anyone to become an issuer, to prove, here's my public key, here's my DID. so that we can now have them on a per relationship basis versus one that's an expensive, slow process to get and then becomes easier to attack. So there's a lot to answering that question, but I know Evernham and a few others are collaborating on a paper that compares verifiable credentials with digital certificates. So look for that here soon. Next question, this might be a good one for, actually, I'll wait on Lynn Brooks' question until the end. There's one more question about what I just asked. How can we make sure the verifier can be trusted by the holder? So that is a different question and an extremely good one. The short answer is some governance frameworks that I just showed here in this previous slide. We'll back up to there. Some governance frameworks will also have requirements, typically on verifiers, sometimes even on holders. So the verifiers will have to prove they're a trusted member of that trust community. So it's safe to share, for instance, certain data that they're asking for. And I think we're going to see that as a more common pattern. It's not, again, so that the verifier knows who they can trust. It's so holders and secondarily issuers can trust verifiers. So that's a very good question. Let's see, I'm seeing one more. All these credentials be based on one blockchain like Sovereign? Okay, or different areas-based blockchains. So I want to make it clear, what I was showing earlier, any blockchain and any DID method that works with a blockchain or other, it could be a decentralized file system like IPFS. It could be a decentralized database of a different design. It could be whatever system is trusted by that trust community for anchoring those DIDs, which, by the way, you can still use digital certificates from certificate authorities. What we're creating here is a superset. All right, fantastic set of questions here. And I think what I'll do is I'll keep going just to make sure we can finish on time. All right, so I have actually two more sections, but the primary thing I want to do now is say, okay, so these building blocks I've been talking about, how do we put them together into something that we can standardize on for internet scale trust infrastructure? And John Jordan, the leader of the BC Digital Trust Service, coined this term, the trust over IP stack, for the stack I'm about to show you. And it is actually a dual stack, and the way to look at it is through this grid. Governance is on the left, technology is on the right, but it's a 4-layer stack, but the first 2 layers are about establishing technical trust, cryptographic trust between machines that are communicating. The top 2 layers are how we layer over human trust, based on who will actually issue a credential about what they know about you as a person or as an organization or as a device. And then the ecosystems will build on top of that. So let me take a second just to build up these 4 layers for you. Layer 1, as I was explaining, is notice the word blockchain doesn't actually appear here, because as we've rolled the stack, we've said, at layer 1, we're talking about public DIDs, and whatever those systems are, we just refer to them as public utilities. Sovereign being an example of a global public utility designed just to do this. Each of them will have its own DID method, so that's how they get standardized to support the higher layers above. Every one of these will have a governance authority of some kind, and ideally publishing a governance framework if it's going to be trust over PA compatible. Now, you can have, in addition to public permission networks like Sovereign, you could have a permissionless network, Bitcoin, Ethereum, whatever blockchain technology supports a DID method that will allow for what's needed to support the higher layers can work at layer 1. These 3 roles that you see published here are examples of the kinds of roles you'd have in a utility governance framework. Those are the 3 roles that we have in the Sovereign governance framework for Sovereign as a public permission network. If you're talking about a permissionless network, those roles are minor, and well, you always have transaction authors of some kind, but they vary depending on the type of technology used and the type of governance. So that's how we get to that base layer, again, cryptographic roots of trust. Now let's go to layer 2, and this, by the way, it was HyperLedger Indie project was designed to say we need this functionality at layer 1. The reason the HyperLedger Aries broke out was because at that point, many people are associating, oh, my wallet and my agent, it's a sovereign agent, it's a sovereign wallet. No, that's not the right way. I mean, it could be done that way, but that'd be a little bit like saying, oh, this wallet here is a Washington State wallet, and I can only put Washington State credentials in it. I live in Washington State in the U.S. Well, of course, it's not a Washington State wallet. It's not a U.S. wallet. It's not a retail wallet. It's not a health wallet. It's a wallet. It works whatever credentials I want to put in or whatever credentials I want to take out. That's what we need at layer 2. And by the way, this happens to be this device I'm holding up. Yes, it's an iPhone. It has a digital wallet in it. Unfortunately, it's a proprietary wallet from a vendor I personally use a lot of devices from, but I'm not happy that the credentials I put in the Apple wallet are proprietary to Apple. They're not portable anyplace else. I can have some control over them, but they're not my credentials that I can move to any wallet of my choice. The goal of layer 2 of the trust over fee stack is independent portable agents and wallets that can work with anything in the stack. Just the way any device you connect to the internet today can talk to any other device on the internet, as long as the two of you can connect IP addresses. So governance frameworks at layer 2, by the way, they're all about, can you trust the hardware, the software, or if it's an agent hosted in the cloud, the agency, does it meet your security and privacy and data protection requirements? So again, that layer supports anything at the next layer up, which we call the data exchange layer. And that, of course, from a trust standpoint, is the home of the trust triangle. So ideally, any issuer can issue any verifiable credential to any holder who can provide a proof to any verifier, just the way it works with these wallets here today. Doesn't mean that any verifier is going to trust any issuer or that they'll take any credential. They all make those decisions independently, but it would all work across, again, on top of layer 2. Layer 3 is where we have credential governance frameworks. For instance, the governance framework behind a MasterCard as a credit card, behind a driver's license, a passport, employment ID card, whatever it is. Those governance frameworks, and they can build in things like credential registries. They can say who the authoritative issuers are. They can even specify there's insurance policies for those credentials. And finally, layer 4 at the top of the stack, that's the application layer. We refer to these, what we're able to support there is entire digital trust ecosystems. And the governance authorities for those are actually working across all the layers below, potentially across a number of other governance authorities, setting up a whole ecosystem. Good example, British Columbia as a province, or Canada as a nation, setting up an entire digital trust ecosystem. They're well on their way, Canada with the Pan-Canadian Trust Framework. And other examples I've used before, MasterCard, NHS, those are whole digital trust ecosystems, multiple governance authorities and credentials operating together to provide the trust that ecosystem needs. So I'm checking time-wise, we're doing pretty well. I'm going to, I think I'll wrap up and then we'll take the rest of the questions. So this stack, the trust over IP stack, the way we think about it is it's a tool for any governance authority and trust community to decide how it's going to implement digital trust. And it starts with that authority and community to decide what are its business requirements, what are the problems it needs to solve, for its community. Those requirements then are the flip, and the way to think about this is don't go straight to technology. Design and write your governance framework. The set of policies you need, decide what levels matter to you and what type of, you can create an ecosystem governance framework that has requirements all the way down. Or you can say, hey, in Finland, for instance, they're creating a layer 1 utility because that's the problem that they think they need to solve initially. So wherever you need to have governance at one or more levels, that's what, once you know what your policies are, then you can make your technology decisions. And we're building, again, the interoperability of the stack to support them. All right, so lastly, I'm just going to quickly explain the value of the stack as a tool like that is gets stronger and stronger as we standardize it, we harden it, we provide examples and implementation communities around it. That's the purpose of the new Trust over IP Foundation. Was launched 3 weeks ago. It's hosted at the Linux Foundation, just like HyperLedger. It's a sister project, not a HyperLedger on one side, Decentralized Identity Foundation, or DIF, on the other side, and of course all other Linux Foundation projects. And we launched with 29 members initially. These are one screen of steering members, another screen of steering members. You'll see IBM, MasterCard, MITRE, SIGPA. SIGPA, by the way, is a Swiss company that does most of the world's currencies and passports. They're, very secure physical documents. Now they want them to be secure digitally. And then we have a large number of contributor members, of which I'm happy to say UBC is one. So congratulations there. And this is the way that we describe the role of the Trust over IP Foundation. It's not to have to create all the standards or components that go into the stack. It's to build the, to define the interoperability needed on both the governance and technical sides, and then have interoperability testing and certification against that, so we can have a uniform trust layer for the internet. We have these there's a steering committee composed from the steering members. We have these 4 working groups, one each for the technical and governance stack, and then what we call the foundry groups, which is community practice for either utilities at layer 1 that want to come together, work together on their common problems, or ecosystems forming at layer 4, because those are the 2 places we see the most interest early on. And that means there'll be a whole set of projects that we're going to be spawning coming out of this at these 4 layers, whether those projects are inside the Linux Foundation. There are already several new ones that are coming to the Linux Foundation to do the collaboration there, or wherever you are in the world, right? Finland, I've used the examples formed FINDI, Finnish Indie, because they want a public-private collaboration in Finland. And they've realized it actually is going to go all 4 layers of the stack. It's going to be an ecosystem with a utility at the base. It's all hosted HyperLedger Indie network in Finland, but they're going to have provider standards, a standardized set of credentials, and overall ecosystem rules. So anyone listening to this webinar that's saying, oh, I'm part of a trust community or a governance authority that would want to do this, it's what we're creating this tool for. And that's it. Actually, I'll leave it on that slide as we go to questions and how much time we got. About 10 minutes. So I don't know, Victoria, if you want to moderate the questions or how you want to proceed.
I'm going to let you select the questions that you really feel compelled to answer. So yeah, and then I just want to take a couple minutes at the end to just talk about how UBC is involved and how we would like to support the Trust over IP Foundation. So go ahead.
That's wonderful. Okay, I think I see a manageable set here, so I'll keep going. So one of the questions, could this infrastructure be kind of a next generation of current PKI? The answer is absolutely yes. In fact, that new generation is being called DPKI, decentralized PKI. That's actually the name of a paper that was produced at the first Rebooting Web of Trust conference about 4 years ago. Amazing gathering, about 55 people in San Francisco, and Vitalik Buterin of Ethereum was there, Greg Maxwell from Bitcoin, and Juan Bennett from IPFS, and it was just a super cool gathering. It started the whole Rebooting Web of Trust conference series, which has happened every 6 months since then. And we had one team of about a dozen of us produce a paper called Decentralized PKI, and it was the basic premise of what you're seeing here. And now, of course, the stack has grown a lot in understanding sophistication since then. But yes, we believe this is the decentralized PKI of the future. And it, by the way, it will be a superset. So existing PKIs will not go away, and existing certificate authorities, rather they will become part of this larger network. And just to put a fine point on that, two of the largest certificate authorities in the world, DigiCert here in the US and InfoCert in Europe, are very active, both sovereign stewards, and they're both actively working on this infrastructure for their customers. So that's that question. I'll take the next one from Lynn Brooks. How long in the future, whoops, it moved around. How long in the future do you see user adoption of an individual's current wallet ID contents being duplicated or functional on their DID SSI virtual wallet? That is a great question. My answer is going to be, think, for those of you who can remember, I've got enough gray hair, about the first time you used a browser in the early days of the web. There were not a lot of websites, but it was clear what was going to happen with the web, right? As soon as you saw a website and used a browser to move from page to page, oh man. And then, you know, pretty soon you heard about the next site and the next site, and then your company created a site, and then you created a blog, and that's how the web grew. We believe the same thing is going to be happening with digital credentials. We're just seeing the first ones out there to solve the most pressing issues, like doctor mobility for COVID, right? But there are dozens. I mean, that's what Evernham as a company is all about, is helping our customers with where do you want to introduce and start using digital credentials, and what kinds of problems. Are they regulatory compliance problems? Are they efficiency problems like the doctor's passport? Are they developing new kinds of trusted applications to do things you can't do online today, like, you know, apply for a loan entirely remotely with adequate levels of assurance? So I think it's going to be a sort of gradual, and then sudden, very much the way the web was. How far that knee out is until it's really, you know, most of our credentials are in the in digital wallet. I'll put it this way. It won't be faster than 3 years, but I don't think it'll be longer than 10. And you can sort of draw the curve in there. I think that within 5 years, a significant set of the credentials in this wallet will be available, and within 10, they all will, or nearly all of them. Okay, so that's that one. Can the verification processes scale at MasterCard transaction volume levels? Yes. Short answer, full on yes. The reason is that the blockchain component, which is where you might think the scalability bottleneck is, in the architecture I showed, where it's only being used for DID verification for public issuers, it's not, transaction load is not high. You can be literally verifying millions of credentials, and those DIDs and the associated DID documents do not change very often. So you have, it's a very it's a short-lived caching policy, but you don't have to hit the chain every single time you're verifying a credential, and you can absolutely, it's should be every bit as scalable, if not more so, than DNS. So there's that one. Okay, I'm trying to stay up with them here. Will there eventually be a kind of global master governance framework model that curates several rules or governance frameworks of multiple governance authorities, like credit reporting agencies? I think so. In fact, I think there will be several of them. Basically, the higher you go, and the ecosystems can contain ecosystems. And basically, the higher you go and the broader the rules you can agree to, the bigger, the more easy, the easier it will be for your network to evolve and to accommodate many within them. So the level of interest we're seeing right now at the ecosystem level, I think underscores that yes, you will see those very broad governance frameworks, because that's how you can really get scale. Okay, the next one. Where can we see in more detail business models using SSI, and how much does it cost to publish or consume a service like this? So one place where you can see those discussions going on is Internet Identity Workshop happens twice a year. The last one was, I think, 3 weeks ago. It has a whole sort of subtrack on SSI business models. There's also at least one firm in the space that I know is focused specifically on that. It's called Digital Trust Ventures. If you just Google digital trust vendors, you'll find Timothy Ruff and Sam Smith. It's one of the first boutique VC funds. It's focused exclusively on SSI and business models for that. And they're actively involved in discussions. There's also discussions about that going on at the Decentralized Identity Foundation and also starting in Trust over IP. So I hope that. Next question is actually really easy. HyperLedger Aries is at what stack level? 2 or 3? The answer is both. It's primarily initially focused on 2 for interoperable agents and wallets, but the credential exchange protocols needed at layer 3 are also being developed there. Now, whether they will stay there or that will become another project is an open question, but currently HyperLedger Aries is levels 2 and 3. Indy is basically level 1 with stubs into layer 2. Tell me at any point, Victoria, when I think I've only see a couple more.
A couple more, so if you want to address those and we can just hang on for a couple more minutes, I
sure.
think it's great.
That sounds great. Actually, I see 2 more. Do you see a specialized wallet or one wallet per person? Really good question. I think the answer, ironically, I'm going to give you is both. And that's because what we are seeing is 2 types of wallets, specialized wallets and general purpose wallets. And by specialized, what I mean is you'll see wallet capabilities built into an app, existing apps. There are way too many of them out there, and they want to add credential support. And they don't want to have to necessarily delegate out to a general purpose wallet, such as the Connect.me wallet from Evernym. That's designed to be a general purpose wallet. But what we're seeing is and we were thinking, well, a general purpose wallet will do all these things just like an operating system or a key ring takes care of those things for a lot of apps now on PCs or Macs. But what we're seeing is, no, you need both. You need a place where you can deal with all of your credentials, like a general purpose wallet, but you also need support for credentials in specific apps. Ideally, they can talk to each other. So if you get an app that gets you a new credential in a specific app, now it becomes available in your general purpose wallet and vice versa. That's the way I think it's going to go. Evernym has produced a mobile SDK for that very purpose, and so are other vendors in the industry. I do believe it's going to go down to the OS layer, and we'll just see how fast that happens. All right, I guess one more question. Finally, would it be a public or private governmental blockchain? Let me read the rest of the question. If public, what would be the sensitive to the blockchain holder nodes, miners, stewards, etc., to make the blockchain as distributed as possible? Okay. So here I think the answer is you will see all manner of blockchains at layer 1. You will see public permissionless blockchains like Bitcoin and Ethereum. You will see public permission like Sovereign and other HyperLedger Indy-based networks. You also even see private permission, like within a government or a closed community industry consortium. You can develop DID methods that are completely standards compliant for all of those. And that's what the agents and wallets will use. And they can work across those. So I think now some blockchains, such as Sovereign is a good example, said our whole purpose is to provide SSI infrastructure. It's a nonprofit organization. So diversity of stewards, the trust institutions run the nodes, is a prime consideration. They have, I think it's about 63 or 4 stewards in Sovereign right now. They're all around the world. They hosted on different systems. So diversity is a major feature of Sovereign. At the other end, you have something like Findy, where in Finland, the whole requirement is all the nodes are operated within Finland by different institutions. They want to treat that as critical infrastructure. Neither one is right or wrong. They're just different governance authorities for different trust communities. And the beauty is the more we have, the more robust trust infrastructure we'll have for the whole internet. And Victoria, I'll stop there.
Wow, thank you so much, Drummond. That was super interesting, so well explained. And, I'd just like to thank you on behalf of everybody. Our participants, before you head off, I just wanted you to know that, as Drummond mentioned, Blockchain at UBC is involved in the Trust Over IP Foundation. If you are a student, then we actually have active SSI projects going on based on HyperLedger, Indies, Aries, etc. And so this is a great opportunity to get involved. You can get involved at any layer of the stack. You can get involved in governance as well as the technical aspects. There is room for everybody, and we're multidisciplinary, so we need all perspectives. And I will also just say that, we'll be sending out, for those who aren't students, we'll be sending out a link to the recording of Drummond's presentation here today through our Blockchain at UBC newsletter, which is coming out in a matter of days. And so if you're not subscribed to our newsletter, please do so, and get all of the news from Blockchain at UBC. We would love to have you actively involved in our community and helping to support and grow the Trust Over IP Foundation and all the other really cool and great blockchain DLT initiatives that we're involved in. So thank you again, Drummond. Really super to have you here. We'd love to have you back sometime. But for now, we'll just say bye and take care, everybody. Stay healthy and enjoy. Take care. Bye-bye.
Thank you very much, Victoria. Look forward to talking again soon.